connect on Twitter, and you can follow all of that stuff. So maybe if we move over to some of the demo type stuff, really, that we were going to show some of the products, some of the applications that we've taken on the road. We'll look at some of the comments that have come out in the broader. After this demo session, we'll look at some of the comments that have come out from maybe leading luminaries and developers around the world, and also some of the things, some of the fun things that developers have done with these that actually show some serious points, as well as some of the pieces that people have found they've been able to move their applications over mostly wholesale from Windows to Mac using these technologies. So Pavel, do you want to take presenter rights? Are you ready for that at the moment?
Yeah, sure. Let me actually see. Okay, I now need to.
If there's any other questions in the meantime, I'll just check to see if there's any other presenters. You taking it?
I'm not sure if I can actually show my screen. My screen is actually disabled for me.
Let me just flick you over to presenter.
Okay.
That's what I need to do to start with.
Show my screen. Okay, so now you should be seeing my screen. So I was thinking actually you should actually see my Delphi. I hope you see Delphi. Okay, so maybe I've been talking a lot about this Bezier surface. So maybe I start from this little demo just to give you a little bit of a feeling what I have done. And this basically shows that you can actually create FireMonkey for both Windows, Mac, and also for iOS. This is actually an application created for Windows and Mac. So basically, when you create a new application in RAD Studio, first of all, you have a choice between C++ and Delphi. And once you are within Delphi, you can create actually 3 different types of FireMonkey applications. So 2 types, FireMonkey 3D and HD, these are the Windows and Mac, and there are also 2 specific types for iOS. So this is actually this FireMonkey 3D application. And you can actually, when you run this application, and now it's actually compiling for 64-bit, you can see that I can compile it for different platforms. And this is actually, you can load the mesh object, and you can rotate it very easily. You can actually see at the left-hand side there's some statistics about the mesh itself, and so the number of vertices, number of indices, and it's really below 1 millisecond to generate this mesh. So these other functions from Anders, they took a few milliseconds, like 8-10 milliseconds. This one is actually less than, after rounding, it's probably less than half of a millisecond to generate this. Also, you can actually display this as a wireframe, or you can display it as a solid model. You can use this for rotation. And it's really, you can think about creating all kinds of very innovative user interfaces, and it doesn't have to be boring. It can be quite interesting. And basically, this is the whole source code for my application. So basically, every button here is hooked to the same event handler called button AnyClick, and every of those buttons has different tag value, so from 1 to 7. So depending on which button you clicked, then you will get to the same handler. And basically, depending on the ID, this is the code to generate the mesh. And I have a special mesh bicubic unit, and this is actually where I put original source code from my Turbo Pascal 5.5 days. In fact, you can actually see this is the source code of this. This is the source code that was used as is to generate this matrix. So this net variable is an 11 by 11 two-dimensional matrix of 3D points that makes up the whole thing. Actually, what I can do, and I think it's quite nice, I can actually go again to my to my my Windows machine. And what I do have, I have actually my original DOS application. So if you look into my hard drive, I have a special TP folder where I have actually compiled versions of my Turbo Pascal applications. I no longer have a working compiler, but I do have this application compiled. So you can actually run this in DOS. So I have a DOS box. You can actually, in order to run something, you need to mount first a specific directory. So now I have this directory with my executables mounted as C. So if I now go to the C drive and do a dir, then I can see that this is where my original files are located. And this is actually an original Turbo Pascal 5.5 application running, and you can actually, it was some of my first takes on having an interactive user interface. So this is all obviously written, so you can actually select which view you want, and you can actually zoom in separately this particular view. So this is actually a real application created something like, you can see, 1991. So that was a few years ago. But that's actually showing some of the really cool possibilities around FireMonkey. And actually, I'm going to steal some more time, and once I'm presenting, I want to show you something that I have done yesterday. And basically, this is a Meteors game. You probably remember this classic Atari game of Meteors. So that was actually a demo that was originally shipping with a C++ product backed with an object Windows library. I think it was 95 that we have this OWL, Object Windows Library, something, the library before the Visual Component Library. And my colleague from the UK office, Roy Nelson, one of the best Delphi experts I know about, actually took this old C++ code, OWL code, and moved it to Delphi and to the VCL and to the GDI. And this application that you now see on your screen is actually a refactored version of this VCL application. So what I have done with this existing code, first of all, I have removed some of the code that was directly in the form itself into a separate unit. So refactor as much as possible from this FireMonkey, from this VCL form to have a unit that can be more independent. So I have different classes here. There is a basic sprite class that has some basic functionality and virtual abstract method for drawing, and there is a sprite list that can iterate through all the sprites and draw them all. And there are different objects like meteors, like shots, like debris, like a ship, so, and a sprite message. So these are the different types of sprites that are uniformly handled through this sprite list collection. So that was actually, this code is based on actually on a VCL. So you see there is a canvas from the graphics, VCL graphics. So basically, I wanted to move this code to FireMonkey, to Mac, and to iOS. So basically, the idea here was to actually, first of all, try to reuse all the game logic that is not connected with drawing. So this code should be directly portable. So basically, I have also, like in Delphi 2010, when we introduced a specific Direct2D support for Windows 7, I have actually moved this application then to Direct2D. But now we are using FireMonkey on Windows is also using Direct2D for drawing. so that's actually no point anymore. But basically, that's my original GDI version of the application. And then this is the second one is actually a FireMonkey application. So what I have done is actually to take this logic from the form, and it was very straightforward to actually move this to actually my FireMonkey form. There were some little things. For example, notice here to find out what is the key, we have this WK left, and now without the underscore, and in the past it was with the underscore, so there was one thing to change. But otherwise, this game, the form logic is the same. And now with the sprite unit, I have a different version that actually is now using a FireMonkey canvas and not the VCL canvas for drawing. So there were some, actually the most of the work was related to the fact that FireMonkey is using floating point coordinates and not integer-based coordinates for drawing. So I had to change in quite some places, for example, from T-rect to T-rect F, and from T-point to T-point F. And basically, the logic for drawing is quite straightforward. So you can actually see that I have the canvas, which is the FireMonkey canvas. It's something very interesting because it is an abstract class that is implemented on Windows with a special DirectX 9 based class, and on Mac with an OpenGL based class, and on iOS with an OpenGL ES class. So basically, with FireMonkey, you just call the methods of the canvas class, and then you can write code that is portable across different platforms. So that's a very powerful thing. So you have on canvas method, you have things like, I can actually show you this class. So this is the canvas class. So these are all the methods that can be used across different programming, different operating systems. So specifically, most of the time you will be, for drawing, you will have things like draw line, fill rect, fill path, draw polyline, and those kind of things like this draw polygon, where you just specify the points. And also with FireMonkey, those drawing procedures are also taking the opacity parameters, so that's something you need to provide on FireMonkey. So basically, I have copied this file, replaced some of the code for drawing. So you can see the debris is just a drawing one line, and you basically, the draw line will take the coordinates of the starting point and the end point, and you can actually draw line very easily. So this is a little bit more complex code to draw a sheep, and yeah, that's actually all very straightforward. So it's not that FireMonkey is for writing games, but these games, especially is something that programmers like to write. So I don't want to give you an impression that FireMonkey is for game development, is for business applications, but that's also nice to actually try to move some existing code, like this code, and see what kind of things you can encounter. So this application is now running as a FireMonkey application. I can actually compile it for Windows 64-bit, and also I can, with no problems, I can actually just change the profile, and I can see if I can write connect to my platform assistant server running on my on the actual Apple machine. I can. So now if I run this application, I can see now that this is now going into the into Mac. So now I have my exactly the same source code with no changes now running on Mac. And as a programmer, I don't have to worry that on Windows it's a DirectX or Direct2D, and on Mac this is different libraries. Okay, so the next logical step for me was really, okay, how would it take to actually move it to iPhone, to iOS? So of course you cannot have it in the same project. So basically what I did I created a separate iOS project as a FireMonkey HD iOS, and created a brand new form for FireMonkey. So that's again, the idea was to keep it as similar as possible. So, but for obvious reasons, when I started to actually move it, I realized that on a FireMonkey form, that's a FireMonkey form, I don't have keys. I don't have a form key down. I don't have a form key up. So that was a question, okay, how do I handle user input? So I have actually decided to use just a regular buttons and glow effects. So when you press a button, it is enabled. It's like pressing a key on the keyboard. The side effect that you can have more than one key pressed at the same time. Only when you press left, it will be actually disabling right. So it's mutually exclusive. So you don't have a left and to the right.
There's quite a nice effect that Anders has done on some of his iOS apps, isn't there, with like the little wheel and that sort of button activity included in a little wheel as well. But that's something that we can get into in a few weeks' time, that with that sort of standard look, to get from a button-based requirement over through to a touch phone. And I know you see it in a lot of iPad apps as well. It's just where your thumb would go, that you've got that kind of equivalent but very intuitive UI onto a touch device, isn't there?
Yeah. So that's actually it's a slightly different thing. And to be honest,
yeah.
one of the I have this book, iPhone game development, and actually this asteroid game is actually depicted there and using Objective-C. And one of the goals of my exercise here was to see how much easier it is to create an equivalent iOS application. And it's really, it's so much easier to do this in RAP with components as compared to do it in a low level with Objective-C code to actually get the same kind of effects. So basically, let me show you how this actually works on Windows. So when you create, actually you can see that I can do things like destroying my ships, and finally I destroyed it. So you can see actually that when I press a button, the glow effect is actually showing. I have still problems with displaying the score. It's not really working correctly. It is just testing, but it was more to see if I can get it to run. And of course,
yeah. Just while you're showing that, actually, we've had a question come in about FireMonkey 3D, and the question is regarding 3D. It's Hans Lundin has asked: Is it possible to connect a 3D television set that supports 3D with goggles and get the depth like a 3D movie? I know that the guys have actually done effects, a 3D effect on some apps that give you that depth, but I don't know if it's actually like a 3D movie effect, but more like, I guess, it's more like the Game Boy type 3D effect, isn't it, than a video effect? I don't know if you come across any of that, Pavel.
No, not really, but I know what you mean. So basically, just to be able to see the 3D graphics like television. But I have not seen any of those. The one that is quite close is the Kinetics, the work to interface with a Delphi code from a Kinetics device. And okay, so now you can actually see now my meteors just starting in the simulator. So now you can actually see that this is now working also on my simulator. So that's actually probably the most complex FireMonkey iOS application that I have written so far. But I think that's a really good thing.
You've got to fire some bullets soon.
You can really now play with it. But that actually, if you think about it, that's a great story. You can actually see that from one source code, you can target 3 different operating systems very easily. So the changes that I have to make to get from FireMonkey Windows and Mac to FireMonkey iOS was only really these two ones. So basically, on iOS you cannot have units with dots in names. So I had to create a separate unit with different types. But basically, the contents of these files are the same, so you don't have to do much. And I have also changed the default display size to match iPhone display. But otherwise, I have not touched the logic, the code at all. So it was just a matter of recompiling for iOS. So I think that's an incredible story to convince your boss to invest in XE2, because there is no other solution like this on the market today, where you can really, from the same source code, you can target natively multiple operating systems, and specifically iOS. And we are going to discuss this probably, but in future we are going to have more operating systems, including Android.
Yeah, thanks, Pavel. That's it's an interesting first take on all of the different types of platforms that we support in XE2. The one thing that I was going to ask is maybe you could show the guys the form flow and biz flow that works through and some of that stuff. Just I guess actually for form flow, so that it's a very familiar 21st century kind of UI that people might not have readily coded against to date, but how very easy it is, and the structure behind that UI to get that level of presentation to that level as well would be quite good.
Yeah,
we've got time, so you on time.
I wanted to because if you have been on some of the presentation that we've been doing live, that's one of the key demos that we present is the Fireflow demo. That's a demo created by Andreano, and actually demonstrates some of the cool effects around the types of applications that you can now build with FireMonkey. So you can see actually the reflection effect that is created on the fly. You can see the use of FireMonkey styles. So for example, the progress bar at the bottom of the screen is actually not standard, it's just styled. And also the very same the same experience you can actually see on Mac. So you can actually, from the very same code, you can actually create applications that have the same look and feel on multiple operating systems. So that's a Mac version just recompiled to
yeah, one thing that's worth pointing out is that the rendering on through the online webinar service is a little bit jumpy compared to what you actually see on your physical screen, isn't it? It works a lot smoother on your screen.
Yeah, it's much
a lot more frames per second.
Yeah, you can actually see that's some of the important building blocks of in FireMonkey is the use of animations and the use of effects, and also what is important is the new possibilities for creating user interface. So now with 3D capabilities, we can create. You can really rethink the way the user interface is being built. So maybe no longer you need to have a number of two-dimensional classical forms, but maybe you can have just one 3D form with this information from multiple 2D forms presented on a layers 3D. So this is actually, you can see the layer 3D is a very handy component that can be used as a surface to place traditional two-dimensional components. So in this way, you can have a three-dimensional application, but you can interact with typical controls in a 3D space. And also, that's also another interesting thing is the use of the RTTI. So with RTTI, we can actually specify the properties that we want to actually animate using just string and not the property itself. So you can actually see quite a lot of interesting code here actually to set up those changes in position or browsing through the different elements. So that's actually the code from the original demo. And what's also interesting is that this same metaphor was used by Steve Ball to actually go one step further and do this for displaying different information. So in the first demo, we've been actually presenting different images from the coming from the folder, but now we can see that the same metaphor can be actually used, for example, for browsing through data coming from a database. So we don't have just one 2D form when we actually scroll through data, but we can do it much more interesting with some reflections, with some animations. So that's really very...
They're all editable, aren't they, as well?
Yes, really, of course, we always use these fish facts, but this is actually the last one. It's not a fish fact. You can see that that's a different form, still using this reflection. So there are really, with FireMonkey, with a 3D, there is brand new world of thinking how to design an user interface that is interesting, that looks modern, that you don't have to be ashamed of. Actually, the next demo, it goes even further. So actually that was a demo created to showcase some of the possibilities inside of the FireMonkey with physics, with some more realistic user interface. So there are 3 components here: magazine stand, postcard rack, and Rolodex, created by guys from Datox from Poland. And this is actually a demo that actually demonstrates browsing through photos, but in an even more attractive way. So I have a folder full of pictures in different types, and depending on your go-to webinar settings, you can actually see this more or less smoothly, but you can see some simulated physics. So these images are not really displayed in a kind of a boring thing, but you have really an impression of a real magazine stand. So you can actually use FireMonkey. These are just components to create a very innovative and interesting user interfaces with simulated physics, so you can actually achieve even better results. So that's a magazine stand. There is also a Rolodex, so that's a different component. You can actually use this to actually simulate browsing through photos. You can actually open this easily, and this is really something that without the FireMonkey and using a traditional methods, that will be very hard to achieve. And these are just components. You can just use them in your application. And probably my favorite is a postcard rack. This is actually presenting the same images from the same folder, but in just another way. So you can see actually that different levels, different rows can independently circle. So that's actually, I think, great showcase of possibilities that the FireMonkey provides for creating innovative and new generation user interfaces.
Just before we excuse me, Pav, just before we show a few more short demos, maybe we could just take a quick poll. Actually, we've got a couple of things we wouldn't mind asking people that are online. Is the first one? Let's fire this one off. Is if we launch this poll, if you can see it as a quick poll, just come up here. Is, are you currently developing professionally using Delphi? So if you just click on that and then submit, that would be great. And we're seeing. So we've got working through, going through as it flicks up. We've got just under 70 people. Yeah, so just over 70% of people, actually 75% of people now, as it settles down. Thank you. Are using Delphi professionally. So I'll close that one off. Here's another interesting one, actually, just to see is if we launch this poll just very quickly. Is how many people are developing professionally using C++. So we normally pick up about, I guess about 20-30% of people around that. If you look compared to the RAD Studio guys, this is settling out, so it's actually just under 10%. Yeah, that's great. Thank you. All right, sorry to crash your demo.
No problem. I was just finished with the demo, so.